I think this is kind of a hard question. The College Board classifies this one as medium difficulty, but I think it's going to overwhelm people because there's so much text in this chart, in these rows, headings, and then the science seems kind of overwhelming. But remember, the thing with any science question on the SAT is it's not about the science. It's about what they say about the science. Treat this as a question where they're asking you to follow instructions, and it's about just going to the right place. So let's take a look. Here we have to complete the statement, so nice and easy. Let's read the passage first. After a volcanic eruption spilled lava into North Pacific Ocean waters, a dramatic increase of diatoms, a kind of phytoplankton, near the surface occurred. Scientists assumed the diatoms were thriving on nutrients such as phosphate from the lava, but analysis showed these nutrients weren't present near the surface in forms diatoms can consume. However, there was an abundance of usable nitrate, so the nitrate is what matters, a nutrient usually found in much deeper water and almost never found in lava. Microbial oceanographer Sonia Durman and colleagues believe that as the lava plunged nearly 300 meters below the surface, it dislodged pockets of this nutrient, releasing it to float upward, given that. Okay, so it's about the nitrate, right? So there's an increase in the nitrate. That's kind of what I'm going for here. That's kind of my dumb summary. So let's just look at the choices and see what we got. And look, it does seem to be that there's lots of nitrate in the lava, right? So this is where the lava is. This is no lava. So it seems like those are bigger numbers. So at choice A, at 5 to 45 meters below the surface, the average concentration of phosphate was about the same in the seawater in the lava-affected areas as in the seawater outside of the lava-affected areas. So this is a good example of, like, if you've gotten a good dumb summary, you don't even need to worry about this choice. It's not about the nitrate. It's about phosphate. The whole point of the passage is the phosphate does not matter. They start with it to mislead you, but then there's this big however right here, right? And the nutrient, the phosphate, is not in a form the diatoms can consume. So they're giving you this information about the phosphate, but they're doing it specifically to mislead you because it does not matter. It is a nitrate that matters. So I'm not even going to bother to check this choice for its accuracy because I know it doesn't count. It doesn't mention the nitrate at all. And people are going to waste a lot of time looking at a choice like this because it's got a lot of similar words, right? It's the same in the seawater in the lava-affected area as in the seawater outside of the lava-affected area. So there's a lot of similar words and then one word that's different that tells us where to look. So a lot of time can be wasted sometimes if you don't know what you're looking for based on what the passage is saying. Let's look at B. For both depth ranges measured, the average concentrations of nitrate, hooray, were substantially higher in the seawater in the lava-affected area than in the seawater outside of the lava-affected area. So they're saying the nitrate matters. And if we go to this thing, right, that's this row, the nitrate seems to be in the lava areas. So lava here is a clear divide. So it's higher in the lava areas. It's not really there at all in the no lava areas. So that seems to be true. Now, is that what they're saying? Well, they're saying nitrate isn't found in lava. So they're saying it probably got pushed up. Well, I guess because it's there, even though it's not in the lava, it's somehow there where the lava was. So something had to happen there. Again, don't worry too much about the science. They're saying nitrate matters. This choice seems to be saying nitrate matters. The numbers match. Let's move on. Let's look at C. For both depth ranges measured in the seawater in the lava-affected areas, the average concentrations of nitrate were substantially higher than the average concentrations of phosphate. So some of you might be like, oh, that could still be right because the passage is saying that the phosphate didn't matter. So if the nitrate is higher, that's better. Now, that's different than saying the phosphate doesn't matter is to say that the nitrate matters more, right? Those are different things. To say that one is more important is very different from saying that the phosphate doesn't matter at all, is basically zero. Now, is that even true? For both depth ranges measured in the seawater in the lava-affected areas, the average concentrations of nitrate were substantially higher. That is true, right? So 3.1 is definitely higher than 0.17, and 0.4 is definitely higher than 0.09. So this is true, but notice, like, the whole point was that the phosphate wasn't really important. So I like B better for that reason. Let's look at D, though. In the seawater outside of the lava-affected area, there was little change in the average concentration of nitrate from 75 to 125 meters below the surface to 5 to 45 meters below the surface. Okay, but if that's outside of the lava-affected area, and the whole point is how the lava and the nitrate kind of work together, then who cares, right? This is the wrong area. So there's an increase in nitrate in the lava areas. That's kind of what I wanted to do. I maybe add to your dumb summary later on if you need to, but this definitely is, I don't I don't care. Like the whole point is that the lava is what we're studying here. So if we're only looking outside of that area, I don't care. So the answer is B. I know that some of you might still be tempted by C because you're we saw this on a different question where like C feels more complete, right? Like you have to, this might be a strategy here, but like you have to resist this urge to treat your answer like a summary of the chart. We are not trying to capture all the information from the chart, right? So you might be looking at this chart and being like, oh, I need to summarize the nitrate is greater than the phosphate. No, we sometimes leave this information behind. For any other SAT question, math section, reading section, if you leave information behind, that's usually a bad sign. Well, more for math than reading, but it's not a good sign if they gave you numbers you don't use in a math question. But on these reading chart questions, that's kind of the whole point. They're giving you more information than you need, and your job is to sort through it and figure out what matters. So here, they're ending this passage really telling us the nitrate is what does it. The phosphate is irrelevant. So when I answer this thing, the phosphate is irrelevant. The nitrate is what I care about. That's what really, really matters. So I don't know if you've got any other reason to get rid of C, let me know, but I don't think we need another reason. I think it's just about the dumb summary is nitrate is what's important. So I think what happens is a lot of times people on these chart questions as well, they get so caught up in the wordiness of these answers that they try to like find a reason to prove wrong answers right. And they're like, but what if it meant this? What if it said this? Try not to do that. If there's an answer that fits more smoothly, that's the one to go with. Don't waste time proving wrong answers right when you've already got a right answer that works.